Hello, dear viewers. I've been trying to teach myself about analog to digital converters and digital to analog converters. Today, I will be looking at the analog read and the analog write functions on the Arduino. If I may, allow me to share my experience with you. I've been experimenting with a popular, inexpensive module, the PCF8591. Having done a search on YouTube, I am able to find related videos. In particular, I have found videos which make use of both the PCF8591 and the Arduino. One of the challenges is that most sample sketches I have found make use of relatively sophisticated libraries. So I've had some trouble making my own modifications and experimenting with the PCF8591 module. You may be wondering why I am experimenting with the PCF8591. My reason is that the PCF8591 has both an analog to digital converter, ADC, and a digital to analog converter, DAC. It is the DAC that I am most interested in. You see, the Arduino does have a built-in analog to digital converter, ADC, but the Arduino does not have a built-in digital to analog converter, DAC, although it can pulse width modulate, PWM, a signal to achieve a similar output. The function used to output a PWM signal is analog write. A popular criticism is that Arduino's analog write function is not truly analog. It is pulse width modulation, PWM. Personally, I am not bothered, but it can be confusing for those learning. A short explanation is that PWM is actually a digital signal where the duty cycle, also known as the on time, is pulsed. In effect, this PWM signal can mimic a value within a range of voltages. It is useful for most hobbyist intents and purposes. So I have decided to take things a step back and refresh myself on the Arduino's analog read and analog write functions. Bear with me, I'll show some sample code in a moment. Analog electronics are electronic systems with a continuously variable signal, in contrast to digital electronics, where signals usually take only two logic levels, high or low, rather on or off, or 5 volts or 0 volts. Although electronics textbooks point out that signals usually have a threshold for values of what qualifies as on or off. Constructing analog circuits and digital circuits can vary in principle. For instance, digital electronics make use of a clock signal. Microcontrollers like the Arduino are integrated circuits which mainly make use of digital signals. So, what is an analog signal? I was reading a textbook specifically devoted to analog electronics. It had a great way of explaining the word analog. To paraphrase, it was using the example of a live musical performance. The sound of a singer's voice going into a microphone has the same waveform as the amplified waveform coming out of the microphone. Likewise, the output of a loudspeaker is analogous to the singer's voice. All waveforms are analogous, or rather analog. If you would like to see where I found this, please see Creecraft and Gergely on page 2. For a moment, I will focus on ADCs, since the Arduino Uno has one, but to be more specific, the ATmega 328P has contained an ADC. I have come to discover that understanding how the ADC works is complex. I have studied the ATmega 328P datasheet. I admit I don't fully grasp the block diagram nor the explanation. The following is just the basics. You may already be aware the Arduino has analog pins. On the Uno, there are 6 from A0 to A5. These are made use of by a 6-channel ADC. The converter has 10-bit resolution, returning integers from 0 to 1023. The main purpose of the analog pins is to read analog sensors. A temperature sensor is an example. From what I gather, an ADC makes use of power and ground references to create an integer value that represents the analog input voltage. I was searching for a general definition of ADC resolution. According to the NXP website, ADC resolution is defined as the smallest incremental voltage that can be recognized and thus causes a change in the digital output. I've also been reading an old electronics textbook by Boylestad and Nichelski from 1982, which on pages 617 to 620 explains the formula for calculating the resolution as Vref divided by 2 to the power of n, where n represents the count bits. In the case of the Arduino, the n would be 10, and in the case of the Arduino Uno, this is 5 volts divided by 1024, which is 4.9 millivolts, rounded. In other words, Vref 5 volts is divided into 1024, and each increment is 4.9 millivolts. If this is confusing, here is a formula for calculating how an analog voltage is expressed according to the Uno's 10-bit resolution. Alright, so this is a math formula for determining a voltage input value in terms of the resolution value. And here is the formula here, and I've already calculated some values in here to get a result. So I'll start with the formula. So here's an input value. It's an analog value, and it could perhaps be a voltage that we choose or select. Maybe we have a potentiometer and we can tweak the knob and say we know we can do this precisely, and we have an input value of 1.5 volts. If we divide that value by the Vref, which on the Arduino Uno is always going to be 5 volts, then we actually are getting a percentage. And when we take that percentage of the input voltage divided by Vref and multiply it by the resolution, which is 2 to the power of however many count bits are in the resolution of the ADC, which actually multiplies out to 1024, then this is the resolution value. So once again, the value that we have randomly chosen is 1.5 volts, has an input voltage divided by Vref multiplied by 10 to the power of the bits resolution on the ADC. This works out to kind of like 30% of the resolution, which is 1024, equals rounded to 307. Alright, so for the first sketch, I just went to the Arduino website, typed in analog read, and just went for the sample code. And I just copied and pasted it in here. Now, off camera, I have my Arduino hooked up, and very simply I have a 10 kilo ohm potentiometer with the middle wiper hooked up to analog pin 3, and the outer 2 pins on the potentiometer I have hooked up outside to the outside leads of ground and 5 volts. Then in the code it looks like a global variable for a variable called val has been created as an integer value. It's initially set to 0. There's also a variable called analog pin, and that's A3. Then the serial monitor is set up. Then this val integer is being assigned an analog read value, and that value is taken from analog pin, which again means analog pin A3, and then it just serial print ln, serial prints a value and then a line for this int val. Well, let's talk. I've got it verified and uploaded already, and I'll show this off camera too. Just twisting the potentiometer left and right. Alright, so I've just been experimenting here. Right now the values are showing up according to the 10-bit resolution. But what if I wanted to get the numbers on the serial monitor to be displayed in terms of real world voltage or just voltage? Well, I thought, what if I took the value that was being printed and multiplied it by the resolution per step, which is 4.9 millivolts. Even when I look at the Arduino website, it even says that 4.9 millivolts per single resolution step, however they word it. And that's fine, so if I just multiply by that number. Now the problem I was anticipating was that this is actually like a float number because there is a decimal value. So to do this operation, does it convert this to an integer? And considering there's decimal numbers involved, is it printing floats or is it printing integers? I don't know. And then I was wondering if that was even going to verify and upload, and it did. So I'll just show this on camera. It was a success. So verify, upload, serial monitor. Okay, now it's working. So off camera, I am twisting the potentiometer, and now it's expressing values in voltage. Okay, so this last sketch is meant to demonstrate analog write, and on the Arduino website there is the sample code for that. I just copied it and pasted it, and I since have verified and uploaded it. It is similar to the previous sketch with analog write or analog read sketch that I showed just prior, with a few exceptions, it seems. The first one is it's not serial printing. Maybe I can modify the sketch to change that. But also here, there's included this LED pin 9, which is set up as an output, and then depending on the analog read value of analog pin 3, then a value will be written. Analog write, which is like the PWM signal, will be written to LED pin, and there's this separate parameter which is the value of the analog write, which I suppose is up to 255. So it takes this value, which is from analog read pin, which is A3, and then it divides it by 4. And I did it with the calculator. 1024 divided by 4 is 256. So that's neat. So basically it's taking an analog read value with that 10-bit resolution, dividing it by 4, and then giving it a usable value number for the analog write. So I just made the changes. Serial.begin 9600, and now I'm serial printing the val. I'm going to verify, and it still works much the same as before.
So I think I have to turn out the lights for this one. Otherwise the LED is not visible. So if I twist the potentiometer, it's gradually changing the brightness of the LED. Now the LED is not hooked up to the potentiometer. Pin A3 is hooked up to the potentiometer. Pin 9 is hooked up to the LED.